I'm audible, right?
Yes, sir.
Yes, sir.
So, when you're doing any AI problem or machine learning problems, right? So, you need to understand what type of problem it is. So, based on that only, you should be able to design your models. Then you have to approach for AI to solve the problem. Okay. So, anyone of you know, like the basic concept of machine learning, like what that is and what we do. Anyone? So, machine learning, what did you understand by that term machine learning?
Right. You're making the machine like try to recognize patterns, or like make it learn to recognize patterns.
Okay. Some part is right. Okay. So machine learning is nothing but we are telling the machine to learn the concepts like whatever you tell. It can be either text, it can be either image, it can be either audio, right? So as Ashit told, like we are trying to see the pattern. So based like more than that pattern also like we are telling the machine to learn the concepts and those kind of things. So pattern is one part of that concepts like what we are telling the machine to learn uh, from the given data which we are giving. So based on that one, so it is broadly classified into four things. So supervised learning, so unsupervised learning, reinforcement learning, and semi-supervised learning. So coming to supervised learning. So what can you see over here?
A
Fruits.
lot of fruits.
Okay, fruits. So each fruit is it has different names, right?
Yes, sir.
Okay. So this one like we already know like this fruit is this and this fruit is this. So when it comes to supervised learning, right? So what we tell is like these are the classes. So this is the apple and this is the image. So learn from this one. So similarly for other images also, like we are telling this is the class and this is the image. You try to learn from this one and try to find the patterns for this. So for example, if I want to classify some other image, right? So if I give some of the oranges, so it will try to learn from this one. And if I try to give some image of oranges, it will try to predict as orange, right? So other than that, there is what's the similarity between orange and a peach? So color is same, right? Little bit, but the shape is different. So coming into like supervised learning, right? So this would predict the output based on class which you are giving, based on the class which I give, and it will try to predict the output based on that one. So it is trying to learn from the known data. So coming into unsupervised learning. Okay, coming into unsupervised learning, right? So in supervised learning, we know what the data is about. In unsupervised learning, we don't know what the data is about. Everyone's seen this your mails, right? So it would be classified based on your promotion. It can be on different categories, right? So how does it does? Anyone has any idea? So this one, if you have seen in your Gmails, right? So would have seen this primary, social, different kinds of category. So this one, like whatever the text you get in your mail, right? So it doesn't know the data what's inside that one. So it will try to categorize based on like some of the context. So it doesn't have the complete idea. So it will then try to classify that one. So it doesn't have the complete data, or it doesn't have the classes. So it doesn't know the data properly. So that is when we call it as unsupervised learning. And then reinforcement learning. Everyone's seen any robot competition, like it is trying to learn. Recently, there was one drone competition organized by ISRO. Has anyone seen that video or something like that?
I just heard about it, sir, but I haven't like checked a lot about it.
Okay.
So they had to like move around without using GPS or something similar to that,
Yeah,
if I'm not wrong.
you're absolutely correct. So what they did is like they gave the terrain and they gave some particular points where it has to drop and pick up and it has to come back to home. So what it was trying to learn was that like whatever it has been flying through, right? So that used reinforcement learning. So whatever from the previous mistake or whatever from the previous flight it took something, right? So it is trying to learn from that one. It will take n number of iterations or n number of experiments to do, and it will try to learn from that one. It's not one time learning. So repetitive times of learning in reinforcement learning. Mm, for example, I'll just take this example. So it's trying to pick up some rocks over here, right? And it's trying to pick up. So this training, what happens is it is not the first time. It will try to pick up one rock. It will try to pick up second rock and put it somewhere else. So in order to get the final one, if you see over here, 0th iteration, second and 0th. So something it achieved, right? So it is trying to learn from previous experiments. So this is what reinforcement learning is. And then there is something called as semi-supervised learning. So this is the combination of both data is little bit of data is known, half of the data is known, or some other half is unknown data. So that is what semi-supervised learning is. So any doubts on this?
No, sir.
Okay, fine.
Excuse me, sir. So,
Yes.
unsupervised learning, can you teach again?
Unsupervised learning.
Yes.
Okay. So in unsupervised learning, what happens is that you don't know what the data is about, like what that data pattern is. For example, I gave you, what is it? Fruits and images I gave you, right? Okay. So fruits and images I gave you. So this, this has like different categories: apple, pear, cherry, peach, orange, grape, raspberry, and strawberry. So if I give multiple images of orange, so I don't give this different types of oranges is there, right? I won't give this class. It doesn't know what kind of orange it is. So what it does is like always it try to detect it as orange, but I want particular orange type, right? So you're trying to run from this unknown classes. So it will come to know like different oranges are there. So then it will try to classify based on that one. So that is what this unsupervised learning is. It doesn't know the data properly, but it's trying to learn the pattern.
So, like, if it doesn't know, you told that it would like categorize it as orange itself every time.
But
Then
for the first
how?
time, there was some category, right? So on supervised learning, I trained it on different kinds, these types. So further, this oranges has like so many things, right? So it doesn't have that data, but it is trying to like kind of get different kinds of oranges, but telling it as orange. So after that, it will try to give orange one, orange two, orange three, or something like that. It will create its own classes.
So like how does it learn when it like doesn't know the categories at the beginning?
It doesn't need to be have any category. You can just give some images. It will try to learn the pattern, the image what it is, and it doesn't give you as a class. It will give you as binary 0 or 1 or 2 3 or something like that. So it's just like different categories trying to find the differentiation. That's it while learning. So once it find the different categories, right? So you can label that one.
Oh yes, I got it.
Trying to learn the pattern. So you don't know the complete data, but it's trying to differentiate. That's it in unsupervised learning. Okay. Coming into supervised learning problems is there, right? So we know the data. In that, there is four more categories once again. So one is the classification problem. So as I told, we classify something based on the classes, right? It can be fruits, it can be other detection and so on. So mainly they use this classification if there are multiple patterns to learn or something like that. Then there is regression problem. So this regression problem, uh, it's like trying to differentiate something, or you're trying to predict from the data which is continuous data. For example, you'll get temperature data from your sensors or something like that, right? So for you, it will give you till, let's just say for 6 o'clock, you'll get the data. So you need to predict at what time, like for example, at 9 o'clock. So what would be the temperature? So you'd have got the data from morning 6 to evening 6. So based on that calculation, you're trying to predict at 9 o'clock what might be the temperature. So that is what regression problem is. So it's like predicting the continuous data and you're trying to get some logic or some equation. So you can just predict. Then there is time series forecasting. For example, your sales data or your whatever or you do in the stock marketing or finance or something like that, right? So this has timely data, yearly data or something like that. For this month, for example, your sales was something like 5,000 rupees or something. Next month, 5,500. And upcoming month, it was around 4,500. So you might be predicting you will take the average and you might tell 5,000 I might get in fourth month. So that is what time series forecasting is about. So and then there is something called as ranking. So this is nothing just but it's like how do I say? Okay, it's like you are ordering the items based on relevance or your preference. So that is what ranking is about. No first, second, or third you came. You just order them, right? So that is nothing but a ranking system in supervised learning. So it's like finding the most relevant result, like what you're trying to get. So that is what tracking is. Any doubts on this?
So I didn't get how ranking works like here in supervised learn.
Okay. So for example, like in your class, how do you tell someone has got first rank, second rank, or third rank? So based on the percentage, right? For example, like 90 to 100 is distinction. 75 to 90, it's like first class, second class is there, right? So that is the same thing they follow in ranking over here also. So you're just ordering the items based on what you're trying to prefer. That's it. So first, second, third is in your class. In running race, first, second, third, like how do you differentiate and so on like that.
Yes, sir.
Okay. So classification, we know most of the things. So I'll just explain more about regression problem. So we'll be finding it time to time. So most of you are aware of this one, uh, x and y plot, right? So x and y axis, and why do we plot that one? So it's simple linear algebra, right? So we do have that x and y graph because we are trying to correlate something. So what x is in y values or what y is in x axis, right? So we are trying to get two correlations between them. So can anyone explain that little bit? You would have graph theory, right, in your class, or linear algebra? I can explain. What is that? Anyone? Okay, I'll give you one problem. X plus 2x is equals to 15. How do you solve that one? Anyone? So how do you solve this one?
So
What is the
it
value of x?
becomes like 3x, then we divide x value will be like 5.
Okay, x value is 5, right? X is equals to 5. Okay, fine. So then same will take x is equals to 5. X plus 2y plus 3xy is equals to 30. So how do you solve this one? I'll take x is equals to 5 and y you need to find, right? So how do you solve?
Well, like we substitute the value of x, then y will be like remaining, then we find the value.
Okay, so what I told is true. So if we take one value, y we can find it out, right? So similarly, that is how linear algebra works out. You're trying to correlate some values and trying to figure out like the relation between them. So that is what equation is all about. So in linear regression also, what we do the same thing. Uh, it's like we are trying to find out the relations between input features and the output features. For example, I'll just show it to you. Okay, if I give you this one, like what will you understand? So there are three things over here, right? So three data values. So this is x value is nothing but your month, and y values is nothing but your increase in percentage. So this is related to date, and this is related to percentage of increase, right? So if you see like what's the trend, is it increasing or decreasing over the time?
So it's increasing.
Okay, so it's increasing, right, over the time, but at some point it dropped and it increased once again. So what linear regression does is like it will try to find the relation from starting point to the ending point in a straight line. It will try to fit everything in a straight line. So we'll take this one. So like initially it will start at 20 percentage or whatever percentage it has increased, right? So at initial point, some point like let's just say, okay, so just a minute. Okay, at some point like there is some. I'll take this only blue line. So initially we started over here. Okay, so blue I'll take. So the graph values of this one. So initially we started over here. So and the end is over here, right? So let's just say the point is 20 and somewhat blue is 94 they had given, right? So I need to connect the starting and the end. So if I try to connect starting and the end, so this is how it will try to connect. And then there will be some point. So March in March. So this point. Okay. So if you see over here, like there was some downfalls and up trends in or the time period, right? So what I'm trying to do is like in linear regression. So starting and end points. So these are like my initial input and the final output which has to happen. So trend I'm trying to follow. Like I'm trying to give a linear equation so that everything like whenever I try to predict or something in future, right? So it is fitting in that line. So I'll give one equation. So if I try to predict, so it will just fall in that line and I'm able to predict the similar outputs like what has happened. So that is what linear regression is doing. So I won't go into mathematical details in you just understand the concept of this one. So in linear regression, you're just trying to find out the pattern. So it is trying to fit your input to your output. So correlation you're trying to find using a straight line. So any doubts on this little bit linear regression? If you have, you can ask. So this green line is what is there, right? So if I give this blue color all the inputs, it will try to find the green equation for that one. And whenever you're predicting, like it will give you those outputs, like at what time, what the prediction would be, like that it will try to give out.
Excuse me, sir.
Yeah,
So, you said it's going to predict the output. So, we give the blue line as the data, right?
yeah,
Like as the
okay.
input. So does it like predict the equation of the green line or like find the corresponding or like matching
No, it will
one to
find the
the
equation
green
of your green line. And then
line?
once you get those equation, right? So if I want
Mm-hmm.
to have something in April or something like that. So I want to predict in April, like what might be the trend. So it will go up little bit, right? So then it
Mm-hmm.
will try to give the values, missing values over here.
Okay, okay, okay.
So regression is used for prediction, those kind of things, like what might be if I follow this trend.
Okay, sir.
Excuse me, sir.
Yeah, Tanishka.
So, like the green line, so the blue line is the data, right?
Okay.
So then, like the green line is like follows the data. Like here, there's a like downfall in the month of March. Then, like, will it still be straight? Like, doesn't it
Yeah, it will
show
be
like
straight. That is what linear regression is. It is trying to fit in a straight line. So if you want to actually get this one, there are more ways. So there is probabilistic learning. So probabilistic regression. So what it does is like it will try to fit and in the curve also. This one like it is trying to learn in straight line, right? So this is what linear regression is. So if you come over here, it will try to fit a line such a way that it comes like this. So that is what probabilistic regression is. There are multiple regression. I'm just explaining the basic ones. So if you
so
want to
like
learn this one, yeah,
uh, it predicts based on the given data, right?
yeah,
Like if the data has some alteration, then how does it still? How
data
does
is
it still like if data has some alteration, like there is a downfall here, then how does it still maintain the straight line?
it's just your algebraic expression. It is trying to learn like what is the trend in that one. So let it be downfall would be there, but it's trying to fit everything in a straight line, right? So at some point, like it can be little bit down or something like that. So it depends on your data. That's it.
Okay, sir.
So it can be ups and downs also. It can be up also over here. Sometimes your data would be like over here also, right? Something like this. So let it be. It doesn't matter, but it's trying to fit under a straight line. That's it. So that is the simplest one which you can find. So others are also there. Regression. If you want to have the actual line, like how it fits, you can do that also. Okay. There is one more. This one, like as I told, like if you want to have this, uh, not the straight line, and if you want some actual curves, like where it is trying to learn from the actual data, right? So that time you can use logistic regression also. So, but here what it happens is that it will scale to 0 to 1. So log it can take only to 0 1. So it's like for example, if you have some values in decimal. So if you have some data which is in integers, right? So what you need to do is like you need to have the concept are called as standardization and normalization. So don't worry about that one. So it's just you're converting your data to reducing those two actual values how you want. So just keep in mind in future like you might use. So standardization and normalization. There are two methods where you can scale your data down. Mm, okay. So we'll go into decision trees. So like I'm just teaching the basics of supervised learning, different types. So these are also there, would be there in unsupervised learning. You can use it for that as well. So different types I'm trying to teach, like different data you'll get, right? So what you're trying to solve. Okay. Okay. I'll just ask one question. So in future, like you'd be having some dreams, right? So like you want to become something or engineer, doctor, or something like that. Like how do you decide? Like my question was not right. So in order to achieve that goal, like how do you decide your path? Uh, Anyone can answer. Like what is your ambition in goal to become in future?
For the sake of the example, let's take a doctor.
Okay. So in order to become a doctor, like what you have to do initially in each step.
Well, we'll complete our basic education of like 12 grades and then get into like university or like medical school.
Okay. So initially you start with high school, right?
Yes, sir.
So you complete your high school, then you go for your PU college. So in
Mhm.
PU college, what and all the options you have?
You have like options for CS and bio separately. So like engineering path or like the medical path.
Okay. CU and bio is there, right?
Hmm.
Okay. Then if you want to go into doctor, like you have to take bio.
Hmm.
Then in biology, like if you take those, there are multiple things, right? So one is completely pure MBBS. Then you have your Ayurvedic or something like that. Then you have one more veterinary or something like that. Yeah, right. So in order to achieve this one, like if I go into this, if I go into CS, can do some other courses. So CS, I have engineering. Then something called as BCA is there. Okay. So my goal was to become a doctor, right? So how do I achieve that path? So which just a school path. Yeah. So which path I need to take?
So we go through bio and then through, let's say,
Okay.
MBBS and then through doctor and
Okay.
then to
So this
doctor.
was the okay. You're telling something.
No, 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 that's all. That's all, sir.
Okay. So in order to achieve your goal, like if you want to become doctor, so you have to follow this school you have to go. Like you have to select biology, then MBBS you have to complete, and you have to become a doctor, right? So there is some point. So if my goal was to become an engineer or something like that, so let's just say I want to become an engineer. So what I had to go was go to school. I could have taken computer science or biology. So there was two option also. So this one once again engineer and once again computer science, and I could have completed in two parts, right? So this is what decision tree does. So it decides the path in order to achieve your goal. If your input was some value, let's just say like how do I decide my career path or something like that. So it will give you the probability in each stage. So this is your output. Like if you go this way, it will try to decide the path for you. So that is what decision tree does. So in many cases, uh, so it's like a tree model where from higher branch to lower branch and your desired output, you're trying to get the result. So that is what is happening in decision tree. Mm. Any doubts on this decision tree? So in real case, like it would be the data, like whatever you are giving. For example, this is one, this is two, or something like that. You can give text data also. It doesn't matter. So and whatever the output you give, it would be like probabilistic 0.5 percentage, zero point 0.5. So then this one would be like 0.5, 0.5, right? So once again, so this is the path. So others it doesn't take because you will be having less probability. It will try to give the path. So any doubts on this?
No, sir.
Okay. Okay. Coming into random forest, right? So this random forest are nothing but your n number of decision trees. For example, I'd shown you like how to become an engineer or doctor, something, right? So let's just take. So this is one part of your life. Then you'd be having some other goals, right? So you'd be having some other problem after you become something like a doctor or something. So after that, you'll be having multiple courses once again. So in order to like kind of you'll try to relate it over here. Then you'll be having something over here. So random forest is nothing but your stack of decision trees, one after the other. So taking huge decision trees in one go, it's not a good thing. So what we do is like we'll just divide it into different types of problem statements. We'll divide that one. So instead of one whole big thing, so divide into small things. So we call it as random forest. So then we try to predict that one. So gradient boosting and data boosting also same thing. So you're just stacking decision trees and you're trying to do it in a different types of calculation and predictive method. So that is why it's different. Random forest, gradient boosting and data boosting. Then there is something called as support vector machines. So these are SVMs are mostly used for classification problems. So like mostly like you can use it for regression also, those kind of things. So it doesn't matter. So what it tries to find is like when you classify something, for example, mm, let's just say like there are three things over there. For example, I take it as uh, let's just take it as three fruits, three kinds of fruits. So one is apple, one is grapes, and any fruit is green color. You have your guava or peach or something like that, right? So these three things we'll try to classify. So what it does is like some data points would be there. So for example, I gave you fruits. If you're taking the color, you're taking the size. Some data points would be there. So they would be clustered together. So what you do in support vector machine is that you try to find the line where you can differentiate all three things. So that is what support vector machine is trying to do. So one or two equation that we try to find. So it's like mixing multiple linear regression lines into one thing, trying to find the equation in such a way that you should be able to clearly classify different things. It is trying to find the, we'll call it a hyperplane itself. So you're just trying to find this line. So this is hyperplane. So in order to differentiate the classes. In support vector machine, it is trying to find in different directions, not in one way. In linear regression, you saw it was starting to end point, right? So there is no starting and end point over here. So it can be in any direction. It is trying to find the best line which separates your inputs and you can classify them. Any doubts on this SVMs? So in SVM also there are multiple things. So I'm just going through the main topics. So in SVM, this is the linear one. So this is linear support vector machines. So then there are radial bias function, and then there is polynomial support vector machines as well. So based on like what you do and how you want your machine to learn, you can use those solutions accordingly, like based on the problem, and you can just try to find the best solution in predicting or classifying. Those kind of things you can do. I'm just teaching you uh, different types of uh, methods which you can use. In that, different types also, like in subcategories also are there, so you can use based on what you try to do. You're getting the idea, right, why I'm teaching this one? So it's not just image giving or something like that. So there are different kinds of machine learning things. Then we are trying to classify. Okay. So then there are neural networks. So neural networks, can anyone tell like what those are? Anyone? I'd explain multiple times, right? So anyone can tell me like what neural network is?
So, can I?
Yeah, sure.
So neural networks is a machine learning model which is similar to human brain, or which tries to simulate neurons. So you have neural networks in its name, and it also has layers which connect to each other, which also simulate going through multiple neurons and then giving your output.
So what you told is true. So neural network is nothing but it's mimicking your actual neurons. So we are trying to learn from the data, and we are trying to predict, classify, or something like that. So in that there are input layers, hidden layers, and output layers. So it will in hidden layers. So it is trying to learn the pattern, like how it has to classify, how it has to predict. So that is what is happening in hidden layers. So coming into ANN, right? Okay, a neural network has so many things. So if you remember, I had sent you one text uh, in Python level 3 group, I think so. Having many different kinds of machine learning models. So there you'd have found different types of neural network models, and then transformer models and so on. So coming into ANN model, right? Uh, so it's as Harsha told, it's having input layer, hidden layers, and output layers. So in last class also I told you there are different kinds of neural networks. So based on like how you design your input, hidden, and output layer. So that is how different categories of ANNs are derived. And then there is one more very good neural network model called as convolutional neural networks. So this is mostly used for image, videos, and those kind of things. So for classification, prediction, and then trying to segment like only particular image or something like that to convert to other styles. So this is where you use CNN models. Then there are recurrent neural networks. So these we call it as RNN models. And then there is LSTM models and GRU. So this, what happens is that, so in ANN models, right? So we'll give to input, hidden layers it will pass, and output it will predict. But in RNN models, so it will have a little bit of memory, like what it learned, and it can retain that value in that hidden layer itself, then and there. So using that data, it can try to learn once again. It can be passed back. In ANN also, there is something called as back propagation. So you have to pass the complete output and it has to come back. But in RNN, you can stop in middle, you can come back and you can learn once again. And then there is transformers. So these are like mostly used in your NLP models. So ChatGPT and all your something like that is there, right? So that is where transformers comes in picture. Mm, okay. So this is about neural networks. So any doubts on this? So mostly if you see in today's machine learning problems, right? So neural networks are used extremely like in order to learn for complex patterns and all. So since they have that automatic learning feature of from the input to output, so that is where neural network has more advantage compared to other models. So everyone try to use neural network itself. Any doubts?
No, sir.
Okay, fine. Okay. So this one there is unsupervised learning. So we'll continue in next class. So if you are having any doubts, we can discuss. Anything else? Any doubts you have, we'll discuss, or else we'll wind up this session.
No doubts from my side, sir.
Okay, fine.
No doubts.
Okay, then we'll see you next class. So Tanishka, any doubts here? You can just ask. We'll see you next class.
No doubts regarding today's class. Like in the previous class, you told me to like run few commands. I did, and I still got the same output, sir. Like the
You can
image.
share your screen and we'll solve that one.
So like I tried to run all the commands again. I took the screenshot. Can I share that with you?
Yeah, you can share. You can share your screen, Tanishka.
Oh, okay, sir. So now there's an error, but like I shared the screenshot which I took. That's what I got when I tried to run all the commands.
Can you go little bit above image path? My image is equals to file not found, file found error, file not found error. So it's not able to find the file. You're using the drive mount, right? So even after that one, it's not trying to get. Okay, can you do one thing? Can you give me this IPOINB file? I'll just correct this one and I'll send you this.
Yes, sir.
That will do. Okay. So because you're not able to find the file over here, it's not mounting to your drive. Sample data, it's there.
So like this is not the one. Like I tried to upload it again and run, but I still got the error.
Okay, okay. So you're trying into this one only project files. Okay, I'll just give you another alternative option. So you can just send me this code file. I'll share that with you. But What you need to do is like in your drive is there, right? So you can just create one more folder. You can add that image over there and you can just predict.
Yes, sir. So I had shared.
Okay, sure. I'll look into that one and I'll share that with you. Okay. So any other doubts?
No, sir.
Okay, fine.
So can I stop recording?
I can start up here.